Please subscribe our channel Education Point and press bell icon to get notification of new educational videos.
Hello everyone, you are all welcome to lecture number 236, and today I am going to discuss the how to purify the natural water from radioactive substances, that is the purification of natural water, and that is also known as the radioactivity of natural water. And you know there are mainly two sources of radioactive elements and substances in water. The one source is called natural source. The second source is called, that is, artificial man-made source. And the natural sources are when the water is flowing through rock, sedimentation, through minerals, and there are some radioactive minerals like of uranium element, radium, thorium, potassium. These are all responsible of contaminating the radioactivity of water, and in this way water gets radioactive substances, and due to their isotopes. So the isotopes, they play a very important role. And the other source is that is man-made, artificial, means human activities. For example, nowadays lot of radioactive isotopes are used in hospitals for some medicine purpose, that is known as nuclear medicine, to detect the different type of diseases. Also some nuclear activities to install the nuclear plant to produce the electricity, that is called nuclear power stations. Those activities. Thirdly, the nuclear explosion, underground explosion, that causes the contamination of soil with radioactive substances, and that goes to water, and finally to plant and animal. And once the plant is contaminated with radioactive substances, it is taken by animals, like in a river or in pond where clean water is there apparently, but once microorganisms, they eat those substances which are rich in radioactive substances, it goes to higher animals like fish, and in even neat clean water, sometimes the fishes, they contain 20 to 30,000 times more radioactive substances, which is calculated in either million curie per liter or micro curie. Curie is a unit of radioactive substance per liter. So that is the main problem. And here, with the help of the simple treatment of water, is not possible to remove these radioactive substances. The best way of removing these radioactive substances is distillation. But distillation is possible only for our domestic purpose. Millions of liters of water which is contaminated with radioactive substances cannot be removed by distillation. So there are two methods also. One method is that if you see that the water, natural water, is contaminated with radioactive substances, you keep it for a few hours, maybe for 1 hour, 2 hours, so that there are some radioactive substances which are having alpha and beta activity. It will be settled down, and then you can use the water, because their half-life time is maybe half an hour, sometimes 1 hour, sometimes 2 hours. And second is coagulation method, filtration method. There are different type of substances with which, if it is precipitated out, it will go, or if with charcoal, active carbon, it is filtered, then 90, 80, 95% of those substances, those which are radioactive, are removed. So all these I am going to give one by one. So here, purification of natural water from radioactive substances. Natural waters may contain radioactive substances from natural as well as artificial sources. Natural radioactivity is given to water when it passes through rocks rich in radioactive elements such as isotopes of uranium, radium, thorium, potassium. Artificial radioactivity of natural water is due to its contamination with industrial radioactive wastes from institutions involved in using radioactive substances like hospitals. Natural water may also be contaminated with radioactive elements by nuclear activities like power plant, underground nuclear explosions. These are by human activities. Radioactive substances are accumulated in plant and animals tissues and can be transmitted to man by the trophic chain. So that is trophic chain is responsible, goes one by one and it is contaminated with what in human beings. All measures should be taken to protect natural water from radioactive contamination. These are mainly, there are two important methods. One is, I have already told you, the water may be kept for a time required for the short-lived isotopes to decay and only then delivered to consumers. And number two, all suspended or dissolved radioactive substances are removed from the water and they can be removed by setting. The percentage of radioactive substances can be removed from various filtering materials such as one, if you filter through quartz sand, it will remove 80% radioactive material. B, if it is filtered through active aluminum, activated aluminum, it will clear 94% of radioactive substances. And then C is by charcoal bed, if you filter, 86% will be removed. D, by activated carbon filtering, 92%. The coagulation is more effective if water is turbid, clay is added to contaminated water. By this, radioactivity of water decreases up to 90%. At pH 11 alkaline, some radioactive isotopes such as SR89, BA140, LA140 and CD115 can be removed by treating with lime soda. So, as we know that in natural water, most of the alpha and beta activity is due to rock and minerals, and rock and minerals, they are responsible of creating alpha activity, and the beta activity is mostly by potassium isotopes. And here isotopic form of these elements, they play a very important role. And what is isotope? The concept of isotope should be very clear to all the chemists. Isotope means the elements which are having same atomic number, but they differ in their atomic mass. They are known as isotope of each other. For example, if I am taking hydrogen, in hydrogen atom, in nucleus there is one proton, and outside nucleus in the form of electronic cloud, or you can say in orbit, there is one electron. So hydrogen atom is made up of one electron and one proton. Now if we are putting one neutron in the nucleus, that means one electron and one neutron, one proton, that becomes deuterium, that is isotope. And then again, in the same hydrogen, if we are putting two neutron, one proton, means the weight of the mass of nucleus became 3. But the number of electron, this atomic number means number of electron. Number of electron in hydrogen is same, 1, 1, 1. But if we are putting one neutron in first one, it will become 2. If we are putting in third one with 2 neutron, it will become 3. So, and these 3 will be isotopes. One is hydrogen, one is deuterium, one is tritium. With the atomic number 1 and the atomic masses are 1, 2 and 3. So, the hydrogen is the material for drinking water, and deuterium and tritium is the material for nuclear fuel. So, that is the meaning of isotope. It's a very clear concept. So, here these isotopes, they play a very important role, and they have their half-life time. Some are having 1 hour, 2 hours, some are having 1 day, some are having 1 week, some are having 6 months, some are having 5,000 years. So it depends upon their half-life time. Half-life time means what half amount is going to decay. In that time, that is called half-life time. So here, the natural waters have been found to contain alpha activity, which is mainly derived from rocks and minerals. These are alpha particles. And the beta activity, which is mainly due to potassium content in natural water. So there are two activities, the radioactivity, that is called alpha activity and beta activity. Alpha activity is due to rocks and minerals. That is, I have already told you, like uranium, plutonium, thorium. And the beta activity is due to potassium isotopes in natural water. The most important radioisotopes are radium. That is, it gives alpha activity in natural water, and strontium 90 and cesium 137, that gives beta activities. So these are the isotopes and that are responsible of alpha and beta activity in natural water. The permissible limits are given here. So what are the limits permitted? They are calculated either in, that is, micro Curie per liter. Curie word came from Madame Curie, who was responsible of doing lot of work on radioactivity. Especially she is the one who discovered the radioactivity of radium, and she got 2 Nobel Prize. So in her name, this unit is given. So what is the permissible unit? The first one is, that is radium. Radium's permit is 0.4 micro Curie per liter. Second, the alpha emitters other than radium is 2.4 micro Curie per liter. Third one is radio, strontium and radiocalcium should be 20 micro Curie per liter. And the fourth one is other beta array emitters are 1000 micro Curie per liter. The unit of measurement of radioactivity is micro Curie per liter. So that micro Curie liter is given by this is sign of micro Curie per liter. And sometimes it is also given as millionth of Curie per liter. Some coagulation methods are given here and that are widely used to remove the radioactive substances. One is that is called phosphate coagulation, is very effective in removing strontium 90 isotopes from the natural water. Number 2 is electrodialysis method. Yesterday I have already discussed that from seawater how we can use this electrodialysis method to desalt the seawater, and that method is also very important to remove the radioactive substances which is soluble constituents are generally removed by in the form of colloidal matter with the electrodialysis method. Number 3, by adding clay minerals. So these clay minerals are added And this method is effective at concentration of 1000 ppm or more. The excessive volume of sludge is to handle with extra care. Number 4, adding metallic dust. The radioactive substances in excess of 90%, that is except cesium and iodine. Cesium 137 and iodine 131, it is not removed. Others are 90% removed, can be removed. And the 5th one is, that is the most effective one, that is by distillation. And this distillation method can remove all the radioactive substances, but this is not feasible on large scale. We cannot do the distillation. For domestic purpose, we can use. So here with this, I will stop the radioactivity of water and how to purify the natural water from all these radioactive substances commonly known as alpha beta activity in natural water. Thank you very much.